Hi, my name is Marcel, and in this video I'll be presenting AlphaSearch, an agentic AI platform for price arbitrage in energy systems. This framework leverages multi-agent architectures to optimize battery storage and operations in electricity markets. So, the AlphaSearch framework consists of three core layers working in tandem. First, the data layer handles real-time and historical energy market data ingestion, including pricing, consumption, and grid signals. This layer ensures clean, validated inputs for downstream processing. Second, the forecasting layer. It employs multiple approaches to predict day-ahead electricity prices. This is critical for anticipating arbitrage opportunities. Third, the optimizer layer includes multiple solving strategies which solve the core scheduling problem. Beyond these layers, the platform includes a reasoning module that provides natural language explanations of optimization decisions, making the system interpretable for operators and stakeholders. Setting up the platform is straightforward. First, clone the repository from GitHub, then create a content environment using the provided environment.yaml file. Simply run this line of code and activate it. This installs all necessary dependencies. Now configure your environment variable in a .env file. You'll need a Gemini API key for the reasoning and the forecasting LLM capabilities. If you're using Gurobi for MILP solving, you'll also need to set your Gurobi Web License Service credentials, the WLS Access ID, Secret and License ID. Regarding the repository structure, the Agentic Energy package contains all the core modules. To run individual components, navigate to the notebook directory, and to launch the full application, simply run streamlit run app.py from the root directory. The repository includes comprehensive documentation, test scripts, and example datasets to help you get started. If you have questions or want to contribute, please reach out through GitHub issues or contact any of the project contributors listed here. Thank you, and let's see the demo. Okay, so now let me walk you through a quick demo of the Agentic Battery Arbitrage Assistant. On the left-hand side, we'll have all the physical characteristics of the battery. Things like capacity, initial state of charge, minimum state of charge, and so on. We keep these configurations as they are for the default setup. You can also select the region and the date for the schedule you want to generate. Now, let's use the chatbot to generate some schedules. We can ask, can you help me generate schedules for tomorrow? This triggers the forecasting agent in the backend, and it comes back asking which algorithm to use, and it also shows some recommendations. We choose for now random forest forecast, and it generates the price forecast for the day. The forecast is color coded in red and green, indicating some arbitrage opportunities, times when you can buy low and sell high. This system didn't answer the fully question yet, so it actually follows up by asking which optimizer we want to use. We can choose for now the heuristic algorithm. It triggers the heuristic agent server, which then creates an animation showing when to charge and when to discharge, a complete schedule. It also displays the objective's cost. If you follow the schedule, this is the cost you will incur for the day. Sometimes the plots might not be immediately understandable, so we can ask the agent something along the lines of, why did the agent behave like this? We want to understand what the decision making is, so we ask, can you help me reason out the understanding? This hits the reasoning agent, which returns a narrative explanation along with the diagnostic plots. This will help any stakeholder understand what's happening. It outputs different plots to provide a diagnostic that matches the earlier color coding. Furthermore, the better behavior remains within the defined constraints. You can also chat with the agent more generically. For example, we could want to ask the agent if we can trust these decisions and to what degree can we trust that agent. And even ask who the agent is. Let's try that. When we ask these questions, the system doesn't run any of the pipelines. Instead, the query gets classified correctly as a generic Q&A, routed to the LLM, and you get a natural language answer explaining context. It responds that it's a large language model and an AI assistant trained on large dataset, and advises verifying information with other sources and consulting qualified professionals. It presents itself as a helper assistant. So overall, the assistant summarizes its reasoning and clarifies how trustworthy the decisions are.